Hi, today we're going to be doing 6.6 angles of elevation and depression. And the objective is how do we solve problems with angles of elevation and depression. So everything you've learned so far in Unit 6 with trig ratios, functions, finding and missing sides, and also angles are all going to be dumped into this topic and then applied to using it in order to find angles of elevation and depression. So before we go in depth with these two, the angles of elevation and depression, we need to know what they are and what they look like. So angle of elevation is the angle between the line of sight and the horizontal when an observer looks upward. So as you can see in this diagram, we have the angle of elevation. So the line of sight, BD, is whoever's standing there looking up to the cliff, the top of the cliff, and then we have the distance from that person to the cliff, the bottom of the cliff, so DC. So DC and DB create that angle in between, which is the angle of elevation. So your line, your eyesight to the top of the cliff and where you're standing, the distance from that object in yourself, will create the angle of elevation. The opposite of that is the angle of depression, which is the angle between the line of sight and the horizontal when an observer looks downward. So elevation, you think of elevation, like elevator, height, depression, you're down, so it's depression. So imagine you standing or at the lighthouse, and then you're looking down to see whatever object in the water. So you got that horizontal line, you have your sight line, your eyesight line, which is looking downward, and it will create that angle of depression from where your eye level is to what you're looking at the bottom. So it's the angle of depression. So with those two, angle of elevation and depression, there's something that you will notice about those two. But before we get into that, in this question it says name the angle of depression and name the, oops, it's supposed to say angle of elevation. So while I'm doing that, I'm going to change that. That should be elevation. So let me get that fixed. So this one should say angle of elevation. So name the angle of elevation and the angle of depression in the figure below. And what relationship do you see between the two angles? So with this one, we have two angles that we see. We see this section, PFB, and then we see TBP. So let's look at the FPB. So it's up there, you're at the top of the Eiffel Tower, and you're looking down. PB is your sight line. You're looking down at the bus. So if you're looking down, that means it's the angle of depression. So angle FPB is the angle of depression. So now let's say you're at the bus, someone else is at the bus looking up at the top of the tower. You're looking up. That's the angle of elevation. So angle TBP is the angle of elevation. Now, what is the relationship that you see between those two angles? Again, there may be some answers. You might think, oh, it looks similar, look equal. It's depending on where you're standing, determines the relationship between the two angles. But going back to previous lessons, last year when we talked about parallel lines and transversal lines and what special angle pairs that they create, well, we got two lines, the horizontal line, the top one, and the top and the bottom. They are parallel because again it's your eyesight. The horizontal is always parallel, straight across. And then we have this line, a line of sight which cuts through those two lines. So again, you think parallel lines, transversal. If you thought alternate interior angles, yeah, you're close. Alternate interior angles. So the line, the angle of depression and angle of elevation create that alternate interior angles. And what do we know about alternate interior angles? They're congruent. So then that means the angle of depression and angle of elevation are going to be congruent. So the relationship between the two angles is that they are congruent. PF and TB are parallel, and PB is a transversal line. It's that sight line. All three form alternate interior angles, which are congruent. So that means the angle of depression and the angle of elevation are going to be the same. So whatever angle value you have for FPB, it's going to be the same for TBP. So that's something that you need to know. Angle of depression is the same as angle of elevation. They're both going to be the same. All right, so we're going to do an example based on either angle of elevation or depression. So it says find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts a 18 meter long shadow. Round your answer to the nearest tenth of a degree. So we're looking for an angle. There's a lot of things that we need to know. We need to know what the sides are, how are we going to label them, what ratio we're going to use, and then if we're going to use the inverse function or the regular function. So since we're looking for an angle, we're going to be using the inverse function because they give us, what's given is two sides, and then we need to find which ratio we're going to use in order to find that missing angle. The first thing we need to do is figure out the label for the sides. This is the right angle. The opposite of that is the hypotenuse. The side that is closest to the missing angle or angle that we're looking for is going to be adjacent. And what's on the other side of it is the opposite. So that's the telephone pole. All right, so we have 18 and 12.5. It's 12.5 is the opposite and 18 is adjacent. So that's O and A. So we're going to be using TOA. And I'm going to highlight that so that way we know that we're using that ratio. All right, so now we need to set up our ratio. We know we're looking for an angle. It's going to be inverse. We're using tangent. So that means we're going to do tangent, the inverse of tangent equals opposite over adjacent, which is going to be 12.5 over 18. Now we're going to find the value of 12.5 over 18. That gives us 0.6944, but that is not our answer. That is just the value for that angle that we need to look for. So we're going to do the inverse, and in the inverse, we're going to press that second button on the calculator, and then press tangent, and then put in our number, and then we're going to get a degree of 34.8 degrees, since we're rounding it to the nearest tenth. So I'm going to just write that for this step, so it'd be the second, and then it'd be tangent, and then we type in 0.6944, and then we get our answer. So again, we're doing the inverse. We have to use that in order to find our degree angle, the degree measurement. All right, so that is our angle of elevation, 34.8 degrees. Let's go on to the next one. It says the tailgate of a moving van is 3.5 feet above ground, which is shown here. The loading ramp is attached to the rear of the van at an incline of 10 degrees. So notice that the angle is over here. This is the angle of incline. They ask us to find the length of the ramp to the nearest tenth of a foot. All right, so notice where the angle is placed. Again, so if you're here, whatever object is up here is going to be going down that ramp. So that incline, well, it's decline in this case, will be 10 degrees. So it's going to be the angle of depression that we're looking for. And because the angle of depression is equal to the angle of elevation, So that will show that we can use this angle in this position right here of that triangle. So we have the hypotenuse, which is going to be opposite the 90-degree marker, because when you have the two legs meet, intersect, vertical and horizontal, gives you a 90-degree angle. The side opposite 10 degree is opposite, and the side that is next to the degree is adjacent. So again, notice how the 10 degrees up here, that's the angle of depression, it's equivalent to the angle of elevation, which is going to also be 10. Now you need to know which ratio you're going to be using. The opposite is already labeled, and we're looking for the adjacent side, which is the length from the tailgate to the bottom of that incline. So then we have an O and an A. We're going to be using TOA, and I'm going to highlight that so we know what we are dealing with. So that's TOA. And then we set up everything. So it's TOA, so tan angle. So that little symbol, theta, is the symbol for angle. It's equal to O over A. We place all the information that they gave us. So tangent 10 degrees represent the angle. Opposite is 3.5, and we're looking for the adjacent, which is going to be x. We cross multiply. Find the value of tangent 10. We're not doing the inverse. We're just pressing tangent on the calculator, and then 10. We're going to get 1.1763. We divide it on both sides, and then we find x to be 19.8. Since we need to round it to the nearest tenth of a foot, it's going to be 19.8. But if they want you to round it to a foot, then it would be 20 feet. But I just put the two values. But since we're rounding it to the nearest tenth of a foot, it would be 19.8 feet, which I should label. Again, you need your labels. So I'll put that feet. And that's how you apply your tangent functions to find your angles, your sides, dealing with angle of elevation or depression. All right, next one. The ski run is 1,000 yards long with a vertical drop of 2008, and they want us to find the angle of depression from the top of the ski run to the bottom. So from here, where this little guy is, and we need to find the angle of depression, so what they're pointing, that arrow. Round your answer to the nearest tenth of a degree. All right, so we see that the 100-yard is the slope, which is opposite the 90-degree angle, so we know that's going to be the hypotenuse. And this is our height, 208. But this angle is, if this is a depression, we know that depression is equal to elevation, so that means whatever angle we find here is going to be the same in this area. So I already labeled it. So this is the angle that we're looking for. This is the equivalent. This is congruent, hypotenuse. And we have the side closest to the angle is adjacent, and the one that's opposite, 208, is going to be our opposite. So let's look at what they gave us. They gave us the hypotenuse, which is 1,000, and they gave us the opposite, 208. We're looking O and H. Which trig function? Sine. So we're using so. So then it'll be the inverse, because again, we're trying to find an angle. So it's going to be the inverse function. So sine inverse function equals O over H. We plug in all the information they give us. So 208 over 1,000. We find the value of that, which will be 0.208. And we need to do the inverse. So that means the second function, then sine, and then plug in our number, and then we're going to get a degree of 12.0 degrees for that angle of depression. So that means even though you set it up to look like it's looking for the angle of elevation, it's the same as depression. So this guy's angle of depression going down the slope was 12 degrees. It was a 12-degree decline. Okay, next one. Angle of elevation. They want us to find that from point A to the top of a hill, which is 49 degrees. They already gave us the degrees. If they say point A is 100 feet from the base of the hill, so the base of the hill is right there. It's 400 feet. How high is the hill? So that's the question mark. And we will need to round it to the nearest tenth of a foot. All right, so we need to label. We have our degree already. This is the 90-degree angle, so this is our hypotenuse. What's closest to the angle is our adjacent. What's opposite is opposite. That's what we're looking for. So they gave us the adjacent. We're looking for the opposite. So it's O over A. So we're going to be using TOA as our ratio. And since we already have an angle and we're looking just for a side, it'll be a regular function that we're looking for. So no inverse. So be tangent angle equals O over A. Tangent 49 equals x over 400. We cross multiply. Find a value of tangent. We're just pressing tangent and 49, not the inverse. Oops. And we get 1.150 times 400. And then we have 460 feet as our height. And this is rounded to the nearest tenth of a foot. So if I were to plug that in, that would be, actually it's 460, 460.0, so it's just 460. So that is our answer, and that's how you would apply using the functions, what you're looking for, and labeling everything, so that way you know how to set it up in order to solve for what they're asking you for. Okay, let's go on to another one. Oops, this one's a longer one. All right, so this one is the challenging one. So let's see what they're asking us to do. They say Olivia is in a lighthouse on a cliff right here. She observes two sailboats due east of the lighthouse. The angle of depression, so you got two sailboats, A and B. The angle of depression of the two boats are 33 degrees and 57. They want us to find the distance between the two sailboats to the nearest foot. So we need to find the distance between A and B. This may look like, oh my God, this is a lot of work. But again, you're using what you've learned and applied in this lesson. So for the first thing we need to do, which I already done it, so let me see. Actually, nah. Alright, I'll leave it like that. Sorry about that, trying to just adjust it. So what I'm going to do is label everything that I need to be labeled so that way I can work at this problem. So this is the picture that they gave us. I noticed that the height is broken up into the height of the lighthouse and the height of the cliff. So I just combine those two, it would be 195. Now, the green angle, the angle of depression, 57. This angle represents what this person, Olivia, looking at boat A. So it's 57. So we know that the angle of depression is equal to the angle of elevation, and that's why the angle that I have over here, the angle of elevation closest to A, is 57. And I label this as adjacent because it's the side that is closest to the angle. And of course, this is the opposite side of that angle. For 33, you see ECB is the angle of depression for Olivia looking at boat B. So the angle of angle of depression is equal to the angle of elevation. And it's also 33 for looking at boat B. And the distance from where she is to that boat is also adjacent because it's closer to 33. Now what they want us to find is the distance between A and B. So this is what I put the line as red in a question mark. So in order to do that, we need to know what is the distance from D to B, boat B, and then from D to boat A. So once we find that, then we can find that missing piece. So in order to do that, we got to find out what is that side, that missing side. So for the green one, I create the triangle. I have 195 is the height from the lighthouse to the bottom of that cliff, and then the angle 57, and we're looking for that adjacent side. So we know it's adjacent over, the opposite over adjacent, which is going to be TOA. So we have tan 57, and we set up the ratio opposite over adjacent. We cross multiply. Then we find the value of tangent 57, which will give us 1.540. And then we solve for x, which will give us 127 feet. So that means from the base of the cliff to boat A is going to be 157 feet. All right, so what we did for that, we're going to do the same for boat B. So I drew the triangle. The height is 195, and then we're looking for that distance from the foot of the cliff to boat B, and the angle is 33. We know we're using tangent because it's O and A, so we set up that ratio, opposite over adjacent, cross multiply, find the value of tangent 33, which gives us 0.6494, and solve for x. For that one, we get 300 feet. So that means from the base of the cliff to boat B is going to be 300. So we got 300 for the purple, for the distance, purple distance, and then we have 127 for the green distance. We need to find the red. If you guess that we need to subtract, then you are correct. So we subtract the 127 from 300, and then we will get 173 feet for the distance between boat A and boat B. And that is how we use angle of elevation, or trig functions, all that stuff in order to find any missing pieces of information. So again, I know it's a bit tiny, but we take it step by step in order to find our final answer. This may have seemed, by looking at it, a little bit challenging, but again, when you break it down and then put it all together at the end, you can get your answer. All right, so this is our end of that. So going back as a recap, we learned about angle of depression and angle of elevation. Angle of elevation, it happens when your sight line is looking up at the top of an object. And then when it's depression, angle of depression, you are looking down at the top of an object from a upper view. And the angle of elevation and angle of depression are congruent. Imagine, think about two parallel lines, and you have that sight line, which is the transversal line which cuts through them. It creates special angle pairs, and that angle pair is alternate exterior angles, which are congruent. So this is where we say that the angle of depression and angle angle of elevation are congruent. And knowing how to set up your ratio, what you're using, what you're looking for, you can solve problems dealing with this type of topic. So if you have any questions about angle of elevation and depression, feel free to email me, ask me in class. I will provide you more visual examples for you to understand this fully, so that way you are okay with this. All right, so this concludes our lesson, and see you around.